Hey guys, welcome back. Houston Math Prep here. In this video, we're going to talk about the complement of an event. So, the complement of an event is the set of all outcomes in a sample space that are not included in an event. Let's take a familiar sample space, like rolling numbers on a standard die. Our sample space for rolling numbers on a standard die are the numbers 1 through 6. Those are all the possible outcomes that we can get by rolling a die one time. So let's say that the event A is rolling an even number on the die. Then event A would have the outcomes 2, 4, and 6. A's complement, or A with a C up in the exponent, would be not rolling an even number. So that would be all of the outcomes in the sample space that are not even. In this case, of course, the opposite of even is odd, so that would be our odd numbers 1, 3, and 5. What we can notice about the relationship between an event and its complement is that because the two make up all of the possible outcomes in a sample space, if we added their probabilities together, the sum of the probabilities would need to be 1. Just verifying that with this example, the probability of A in this die example, rolling an even number, would be 3 out of 6, since there are 3 outcomes out of the total 6, plus the probability of A complement. Well, A complement also has 1, 2, 3 outcomes out of the possible 6 in the sample space. So if we were to add those up, we get 6 out of 6, or 1. This relationship will always be present for complementary events. Okay, so let's look at a slightly more complex sample space and see what we can do. So let's say we are tossing a coin and then also rolling a die. So we've got a tree diagram over here to show us all of our possible outcomes. When we toss that coin, we can either get heads or tails, so 2 possible outcomes. And of course, with rolling our die, we have 6 possible outcomes. Using the fundamental counting principle, 2 outcomes with the coin times 6 outcomes with the die gives us a total of 12 possible outcomes. And here they are listed on the right-hand side. So let's say that event A is first tossing tails on a fair coin and then rolling an odd number on a standard die. Find the probability of event A occurring. So we know that we have 12 possible outcomes in total. How many of those first begin with tossing tails and then having an odd number? Well, that would be tails followed by rolling a 1, tails followed by rolling a 3, and tails followed by rolling a 5. So 3 out of our 12 possible outcomes fall into A. So our probability of getting to A is 1/4. What is the complement of A? Well, A complement would be all items in our sample space that are not in A. So that would be, let's see, that could be getting heads and then getting 1 through 6. So any of these 6 outcomes up here where we first tossed heads. And it also includes tails and an even number. So it includes all items in our sample space that are not included in A. So using that idea, what is the probability of A complement? Now, certainly we could count up how many items have first tossing heads and then getting 1 through 6 on the die, or tossing tails and getting even. But we can also use that relationship that the probability of A plus the probability of A complement have to add up to 1. And we can say that the probability of A complement is 1 minus the probability of A. We already found the probability of A in the first part of this example, so we can say that the probability of A complement happening is 1 minus 1/4, or 3/4. Okay guys, that does it for this video on complementary events. We'll catch you in the next one.